Today we're going to teach you how to wire your electrical solar powered boat. We're going to first introduce you to the components of that boat and use your supplied wiring diagram to guide you through that. We have in front of us a board that's set up that corresponds to the wiring diagram, and we'll use that right now to introduce you to the various components. And lastly, we'll talk about the safety features that go into the design of this board. We're going to talk about a high current side of the board and a low current side of the board. The high current carries the large amperage to the motor from the batteries, and it's identified by these heavy cables. These heavy cables should be outside of the cockpit of your boat. And the low current sides are identified with these small wires, and they're used to communicate from the throttle to the motor controller, and from the kill switch to the motor controller and the contactor relay. Let's start with the high current side first. You'll note that the current is going to initiate from the batteries, and these are two lead acid batteries, 12 volts each, connected in series for a total of 24 volts. They're connected by these large welding cables. As we go from the batteries, we'll see a shunt resistor. That shunt resistor is just a fancy resistor. It's not essential for the operation of the boat, but it is very useful in terms of measuring the current flowing through your high current wires. After we go from our shunt resistor, we go into the motor controller. So from our shunt resistor, we go into our motor controller, and the motor controller simply modulates the amount of power going into the motor. It is the device that talks to the throttle and allows you to control how fast that motor will spin. You'll see there are various connections to the motor controller, and we'll talk about those later. But in addition to the motor controller, it communicates directly to the motor. In this case, we have an E-Tech DC motor. It can run on a variety of voltages, and currently it's wired for 24 volts. Coming out of the motor, going back into the motor controller and out of the motor controller, we have what's called a contactor relay, or a solenoid. And this is really just a large switch. This turns the system on and off, and it's what's used by the kill switch in the event of an emergency to disconnect power to the system. As we leave the solenoid or the contactor relay, we go out. We see a large fuse. This is another safety feature, and that fuse goes through a large master switch, and that switch is another safety feature. From that master switch, we go back to where we started, to our batteries. Okay, that's the high current side. On the low current side, it starts at the fuse, or this line off of the fuse. Coming out of the fuse, we have a small 5 amp fuse. In addition to the large 250 or 300 or 350 amp fuse, we have a small 5 amp fuse. Past the 5 amp fuse, you'll notice we have a diode, and the orientation of the diode is important. You'll notice there's a line, and that line should be pointing away from the power to allow current to flow into your throttle. After the diode, there's an optional key switch, which we do not have on the board, and from the key switch we go into your throttle. This throttle, you'll see, is equipped with a spring that allows it to go back to its off or starting position. You'll notice this throttle has several points of wires coming out. The first is what's called this foot switch. It's this switch right here that turns the system on when you engage the throttle, and turns the system off when you disengage the throttle. We have wires coming from that low line and going out into the kill switch. The kill switch is this area right here, and you've been supplied with a customized kill switch. The standard kill switches aren't waterproof, and that posed a problem. So Chuck has diligently sealed your kill switches and supplied a color coding for the wirings, black, red, blue, and green, which correspond to the black, red, blue, and green indications on the schematic. The interesting thing about this kill switch is that it has 4 points coming out. Those 4 points are representing normally open and normally closed positions. Here, when the switch is down, The normally closed positions are indicated by the black and red, and when you open the switch, that plunger goes to the other connectors, and the black and red is open, and then therefore the blue and green are closed. So we have normally open on the blue and green and a normally closed on the black and red. And those are all the components for your electrical solar boat. I want to tell you a little bit about safety and the design behind this wiring schematic. Safety is our primary concern, and so there's a lot of redundancy built into the system. There's lots of ways to turn it off. And as we go from the high current side, you can see the easiest way to turn the system off is just to use this master switch, and turning it off shuts everything off. In addition to that, we have the kill switch, which shuts off the system two ways. It shuts off the system by sending a signal to the motor controller to tell it to shut off. It also shuts off the system by sending a signal to the contactor relay or the solenoid to shut itself off. In the past, we've had issues where motor controllers have not responded as we'd like, and so we've introduced this redundancy. We've also had issues where previous kill switches did not function properly because they got wet. In this current design that sends a simultaneous signal to the motor controller and the contactor relay, we have a redundancy built in such that there are two ways to shut this off, and also this shuts itself off in the event that the kill switch does get wet and self-shorts. The last aspects of the safety for the boat are the fuses, and you'll notice we have a couple fuses, a 5-amp fuse for low current, and this higher amperage fuse, which is 250, 300, or 350 amp. The most important thing to remember for this large fuse is that it should correspond to the components that you're utilizing. You would like the fuse to be rated at a lower amperage than the other components. This should be the first thing that fails in the event that large currents flow through your system. Okay, and lastly, we'll prove that everything works. We're going to switch this main switch to the number 1 or A position. We're going to ensure that our contactor, that our kill switch is engaged. And now we'll utilize the throttle to turn everything on. Good. And now we'll show you the various ways to shut things off. Woody will turn off the motor using the main switch. Wonderful. Okay. And we'll turn on the throttle. And now we'll disengage the kill switch. This is the switch that's connected to your life vest. There we go. And one more. And lastly, you'll notice that if I disengage the throttle, that the switch will also terminate power to the motor. All right, thank you.